Hi everyone. So this is a short video just to review the process of using completing the square to work with circles, and we'll also sort of review how the equation for a circle works. So let's start with that. Let's start with what the equation for a circle looks like, just so you kind of know what your target is. Standard form of an equation for a circle looks like this: x minus h squared plus y minus k squared equals r squared. And when you have an equation written in this form, the h and the k represent the center of the circle, and then r, of course, represents the radius. And so when you do get that number over there to the side, if you want the radius, just remember you have to take a square root. Excuse me. So I'm going to jump right into an example, and then I'll point out how completing the square comes into play. So let's say you're given this equation. So this equation, although it doesn't look like it, does represent a circle. What we have to do is we have to transform it from this form into this form. And the way we can turn something like this into a binomial square, which is what this is through the process of completing the square. So first thing I'm going to check is make sure that my x's are together and my y's are together. And in this problem they are. Okay? So I want to kind of separate this and this, and I'm going to work with these two things separately. If I had to rearrange some things at this point to get the two x's and the two y's next to each other, I would. And then I want to take the middle term here, well, it's going to become the middle term, divide it in 2, so I get negative 4, and then square it. And that gives me 16. And that 16, I'm going to just insert right into the equation up here. So I'm going to really throw in an extra plus 16. Okay? Which I am totally allowed to do as long as I then walk over here and add a 16 over on the right-hand side as well. Okay? You can add anything you want to the two sides of the equation. I chose this because I'm going to be able to factor this x squared minus 8x plus 16 as a perfect square. Okay? That's what completing the square does for you. So now I'm going to do the same thing over with the y's. I'm going to look at that 2y. I might have to move down here for this. I'm going to take the 2 and divide it in half, so I get 1. Then I take 1 and square it, and I still get 1. And then I'm going to take that 1 and add it right back into the equation here, which again, totally allowed to do as long as I go add a 1 over on this side as well. Okay, so I know that looks like a little bit of a mess, but I'm really just doing completing the square with the x pieces and completing the square with the y pieces. And now what I want to do is take the two groups. So I'm going to take this as a trinomial and this as a trinomial and factor them. Okay? So x squared minus 8x plus 16 would factor into x minus 4 squared. Okay, I chose that number conveniently so that it would factor. Plus, and then here, the y squared plus 2y plus 1, that factors into y plus 1 squared. And this goes back to when we were talking about factoring and factoring perfect square trinomials, things like that. But if you're not quite sure why this works the way it does, try foiling one of these back out, and you'll see that it turns into this. Okay? And then that's going to equal, over on the other side, that's now equal to 8 plus 16 plus 1 is 25. And now I am in the right form. Now I am in the form of a circle. Okay? So from here, if I asked you to identify the center of the circle, it would be at h and k. Now, remember that the original equation had minus signs in it. So if your equation has a minus sign, that's great. All you have to do is pull the number. If your equation doesn't have a minus sign, like the y, okay, that means that that was really a negative 1, because when you do minus a negative, you get a plus. So that 1 is really a negative 1, I think you guys will probably be okay with that. We've done that so many times this year. So the center of this circle would be 4, -1. And then the radius comes from the 25, but remember that that really represents r squared. So we would do the square root of 25, and we find a radius of 5. Okay? Not too bad once you get the hang of it. Let's try a slightly trickier example. So here's another example. And this one also represents a circle. Again, it's sort of in disguise. You'll notice that there's a couple of kind of gross things about it. First of all, the x squared and y squared have coefficients on them. They're not just ones this time. We really want them to be ones. We'll deal with that in a second. And also the terms are out of order. Okay, so I'm going to deal with both of those things. The very first thing I would do if I noticed coefficients on the x and the y is get rid of them as soon as possible. So in this case, if I just went through and, sorry, looking for the right color here, divided by 2, that would get rid of those. And I'm allowed to do that as long as I divide everything by 2. So divide this by 2, divide this by 2, and divide this one over here by 2. Okay? And that's going to give me just x squared and y squared. And that's where you really want to begin to do completing the square, is with just an x squared and just a y squared. Secondly, my terms are out of order, so as I rewrite this, I'm going to rearrange the terms. I hope that doesn't bother you too much. I'm going to put the x's with the x's and the y's with the y's. So this would become x squared. Next, I'm going to grab this 6x. And then I'm going to have y squared minus 10y equals, and then don't forget to divide on that other side, -33. Okay, so now we're kind of in the same position that we were to start with on the other problem. So I would start with the x's, x squared minus 6x, start with the 6. 6 divided by 2 is 3. 3 squared is 9. And so that means I'm going to add a 9 here and add a 9 over on the right. Okay? And again, x squared plus 6x plus 9, that should jump out at you as a nice perfect square trinomial. Then let's do the same thing here. I'm going to do -10 divided by 2 is -5. -5 squared is 25. If only I could write as fast as I talk. So I'm going to add 25 here. So I'm going to add 25 here. Okay. And then I'm going to group this up like a trinomial. I'm going to group this up like a trinomial, and I'm going to factor those. And they should factor into perfect squares. Okay. So let's see, x squared plus 6x plus 9 is really x plus 3 squared plus y squared minus 10y plus 25 is going to be y minus 5 squared equals, put all of this together, let's see, 9 and 25 is 34, so -33 plus 34 is just a 1. And then if I were asked for the center, I would say, remember this plus 3 is really a -3, and the -5 is really just a 5, because the formula has minuses built into it. It has to do with all of that transformation stuff we talked about. So like when you want to move to the right, you subtract and crazy stuff like that. And then the radius would be the square root of 1, which is 1. Okay? Okay, so now that we've refreshed your memory on a couple of those, you should have some problems in your pink packet to be working on. Some of them are just, examples that are similar to this, where you have to make the circle and then give center and radius. And then on the back of the page, you will find questions that are directly from the SAT practice tests. A couple of them we've done in class. It won't hurt you to do them again. They're really good practice. But everything is related to circles, and some of them involve completing the square, not all of them, but it's a good way for you to kind of practice all of the skills related to this concept. So, okay, hope you guys have a great day.